Oh, yeah, sure.
It's like practically 3 times.
What's up? All right, we're going to go over it right now. Yeah.
Less than you can include the actual value of this is going to go on. No, because so you're trying to include like an extra. You're trying to say that that number 50 is not this.
All right, guys.
That as well. It's just
So, anytime that the class width goes in perfectly, you're going to have to do a little something weird. I think I've got around to most of the groups to discuss that weirdness with where does 60 go. Do you make a whole new class? No, not normally. So when you do this, the highest was 60, the lowest was 10. And I told you to use 5 classes on a test or something. I'm not going to tell you. It's up to you how many classes to use. All right. And then, so divided by 5, so it comes out to be exactly 10. Anytime that happens, it's going to be a little bit of weirdness for the last class. But everybody should really start at where? For the first class? 10. And then no matter which way you do it, your class width is 10, so I should be able to see that width in between. So 10, 20, 30, 40, 50. All right, that's 5. And now if you do it the book way, it'll look like this. 10, I can't use 20 because otherwise 20 would have 2 places to go. That's not fair. Got a summer home and winter. So then I always have to do 1 less just to make it have a place to go for sure. Except for the last one. 60, I don't want to make its own class because then it would be sort of misleading because the last class would go 60 to 69. And when I make the picture, people might go, you know, somebody actually paid almost 70 when no, they didn't. That's closer to being in this class. So I just, instead of 59, just make it 1 bigger. Now real quick, a lot of you guys, I appreciate you're using the inequalities. That's awesome because it's, again, I'm not going to give more points if you do it. I don't care. Whatever makes more sense. But here's what it would look like. That's why I like this so much better. You can see the class width immediately. And then 20 to 30, 30 to 40. Alright, so what's really important is the last one to be 50. And then just make this less than or equal to, so 60 can go in that last class also. Okay, so I think I got around to most everybody talking about that weirdness. Alright, either way you do it, the picture's going to come out the same. So what do you guys get for the first class frequency? 14. That sounds familiar. 8. Ooh, some dissension. Most of you guys say 4. And the 4's got more emphatic. 4. 1. 3. And if you add these up, 4, 8, 16, thank God, 30. Please do that before you go further, or else you freak yourself out when you get stuff like 110%. You know, I did it even better than you wanted me to, Mr. Wallen. 110%, dude. No, it's bad. So now relative frequency, 14 out of 30 is about 47. Keep going for me. 8. 27? Roughly. I'm with you. 4 would be 13? 3? 10?
Yeah, that was the only exception.
Say again?
That was the only exception.
The last, oh yeah, 3 out of 31 tenths, 10%, beautiful. The rest of them I had to approximate a little bit. So when you add these up, 26, it looks like it's going to still be 100. Is that right? Yep. Oh, you're the math boy. You do it. No. Okay, so the way, if you did it this way, the inequality way, your scale is going to be 10, 20, 30. Excellent. If you did it this way, your scale is going to be 9.5 to 19.5, and so forth. So 9.5, 19.5. They just keep going by 10. Oh yeah, 9.5. The last one is going to be 60.5 because we have to do that little bump up just to pull 60 in. All right, let me stop there for a second. Is everybody sort of with me so far? So this is not very high-level mathematics. It's just a little getting used to how it's put together. Now, real quick, somebody picked up on, this was a relative frequency histogram, but what am I asking for? Frequency. Yeah, because I'm a dork. So you got to be careful what I ask for. Use the right number. So you have to base the scale on these numbers. So the highest is 14. What scale should I use? 2. Yeah, I could use 2. What's happening right now? You guys alright?
Yeah.
Yo. Is everybody alright?
No.
Not at all.
What? Let me in. And or is this something related to what we're doing, or is it something else entirely? So what's going on?
We did it wrong.
We did relative frequency instead of...
Oh! Oh my god. You guys are funny. I love how you react to that. What the hell's all that? Alright. Alright. So now you know. Look for what I asked for. So it's going to be like 2, 4, 6, 8, 10, 12, 14. Yay. What do I put down here? Not euros, right? Not pounds, not dinars. All right. All right. You guys all right? All right, shut the hell up. All right. So how tall is this first rectangle going to be? 14. Yeah, it's the biggest one, right? 14. So most people paid somewhere between 10 and 20. Then the next one's going to be 8. Be right there. And then 4. 1. And then 3 people got some extra stuff done. And of course, there were people that had some zeros and had some much higher. I just sort of cut those out. Got the middle chunk. Oh, dude, yes. Yes. I like the fact that I don't worry too much about my hair, because you can pay a lot of money for your hair, dude. It's crazy. Okay. So everybody cool with that idea? Just be careful about it. I'm not going to take a ton of points off if you do relative frequency and I ask for frequency. What I worry most about is, do you understand the concept of how to put this thing together? The picture wouldn't change, just the scale would change, right? If you did the wrong one of those. Okay, cool. How would you describe this distribution? How would you describe this distribution? Oh, I like it. So we got some skew stuff going on. It's like majorly skewed. I'd say it starts high and goes low. I like it. That's how I could describe this really quickly. Most people paid on the lower end of the scale. I like it. Cool. Okay. I was going to do heights, but it's better if I could do male heights and female heights, but there just weren't enough of each. I wanted to get in the 30s or so, and only 20 of each have filled it out so far. Because what do you think it's going to look like? What shape would it take on if I looked at a bunch of men's heights? What shape would it take? Do you know? Are there a lot of really tall dudes? No. Are there a lot of really short dudes? I don't know. You guys, some of you guys are like, yeah, I like them taller than what they know. I mean, relative to the average, are there a lot of really short people? I'm talking about like here. No. So there aren't a lot here, and there aren't a lot here. Most of us are here, right? So the picture would look like this. This is what's called the normal curve. Guys, because it's what happens normally is there's a lot of people in the middle, a bunch of people in the middle, and then there's very few people on the outside. So there's not a lot of 7-foot tall people, and there's not a lot of 3-foot tall people, but there are some. Most of us are near the mean, near the average. So that's why we call this the normal curve, because if you have a population and they're getting enough nutrition and all that stuff, then normally it would be shaped like this. If you have a classroom of grades, normally they would be shaped like this. Bunch of people in the middle, and then some A's and some F's, right? And you guys have heard the bell curve. When people say they're going to curve your grades, have you heard that? Yeah. When I curve grades, I don't just pick the curve up. I actually change how wide it is also. So I pick the curve up and make it skinnier or fatter, depending on what your grades come out to be. All right. Maybe. Okay. So that's section 2.2 is all about histograms for the most part. Some other stuff in there too. Okay. So let's do a little bit more. I spoiled you guys last time. So hopefully you're not used to getting out as early.
Are we turning this in?
No. That's for you. Yay. So guys, don't put that away. We're going to use the same data, I think, to do this next thing. We're going to get into what's called a box and whisker plots. Yeah. So we're sort of getting into section 2-3. Has anybody ever taken the SAT test yet? Anybody taken the SAT test? Do you remember what your results came back looking like? I mean, what kind of information? Don't tell me your score, but or even the ACT might be better. Sometimes I'll give you this as percentile, like you were in the 87th percentile of this. Have you ever heard of that before? You're in the 50th percentile. What does percentile mean? What the hell does that mean? Would you rather be in the 90th percentile or the 40th percentile? 90th. Exactly. And how is it different from like getting a 90 on the test? Those are not the same things. Because you can get a 90 on the test, and that's the lowest grade. So you would be way down, 10 percentile, whatever. Way down. Okay, let me get you guys with me. So the reason they do that is because what happens to the SAT every now and again? It changes. They make a different test. And maybe they changed it, they just arbitrarily made it a little harder than it was before. They didn't try to, it just randomly happened. So everybody's grade should go a little bit down about the same amount. So I shouldn't be comparing them to the people that took the easier test. I should be comparing them to each other, whoever took that same test. So if somebody got more points on this test and I got less, we might still be at the same percentile. It makes it more fair. It only compares you to the grades on that immediate test. So here's how they work. 90th percentile means, that's how you say it real quick, 90th percentile. What that means is 90% of everybody else scored lower than me. I like it. Cool. It's like if you play golf, you don't want to be in the 90th percentile. Right? Anybody play golf? You with me? You don't want to be in the 90th percentile. You want your score to be low. Right? It's one game where the lower the score is, the better. Right? I like it. Sometimes you watch soccer, it seems like that's what they want, but no. I don't mean that crap. So 90% score lower. So 80th percentile would mean the 80% score lower, so forth. So let's try this out. They don't. I can't get more and more precise when I got a very small set of data. But I just want to use a very small set of data to make it easy for right now. So, for example, let me give us 10 numbers to work with. I should probably count them now. Let me see how many do I got so far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So what would your guess be for, let's say, the 80th percentile? Let me show you how to write 80th percentile very quickly. This is how we write 80th percentile. P80. So what's your guess for the 80th percentile? Don't be discouraged if it's wrong. What's your guess? Just give me a guess. It's all right. What's your guess? Say again? All right, so I got a guess for 29. So why'd you guess 29? Who's talking to me currently? I got okay. A bodiless voice just coming out of the ground. You totally are. Freaking me out. All right, stop showing that off. So it makes some sense because 29 is the eighth number in, and 8 out of 10 is 80%. That makes sense. Is there another guess? Is there another guess? Does that sound right? Or how many numbers are below 29?
7.
So what percentage of the data is below 29? 70%. Oh shit. So what's a different guess?
31.
31. That's also wrong. That's all right. If I'm the 80th, don't worry. If I'm in the 80th percentile, what percent should be above me? 20%. Well, how many numbers are above 31? There's only 10% above it. So here's the trick. It's not even a trick. I'm going to show you the math behind this here in a minute. But right now, where's the real answer? What number has 80% of the data below it, 20% of the numbers above it? 30. The average of those two, right? So P80 would be 30. But I like the 29 as a first guess, because if I want to get to the 80th percentile, I'm going to go 80% of the way into my list. The trick is this. Here's the two-step process for P80. Here's the steps. The first step is, like I just said, take 80% of the numbers. How many numbers are there? 10. And that's 8. So if it comes out to a whole number, you have to average that with the next one. So what's the 8th number? 29. What's the next one? 31. So you have to average it. Anytime this first step comes out to a whole number, you average that one with the next one to get that percentile. How we know so far? So if I had 5 numbers, where's the middle number?
3.
This one, right? The third one. But what's half of 5? 2.5. So anytime I do this process and I get anything that's not a whole number, I round up and take that number. So let's try that one. So here, the answer would be average the 8th and 9th. So that's where we got 29 and 31. Divided by 2 is 30. So what if I ask you for the same set of data, what's P75? Let's say P72. Sure. So what's the first step to figure out the 72nd percentile? What's the first step? 72% of 10. What is 72% of 10? 7.2, right? 0.72 times 10, 7.2. I like it. Gotta be able to manipulate them decimals. 7.2, is that a whole number? No. So anytime it comes out to something that's not a whole number, I just round up. So what's the next number up?
8.
So the 8th number is the answer. So P72 is 29. I like it. Now P73, I don't know if you guys realize, P73 would also be 29. But why should I freak out about that? Is this a very large set of data? Do I have a lot of options for all these different percentiles? No. So a lot of them are going to overlap because there's only 10 numbers up here. They can only do so much. So this makes more sense the bigger my data set is. Okay. What do you think is another name for something like P25? How far into the data would that be? A quarter of the way. So another name for P25 is Q1, the first quarter. So it's called quartiles. We can even go down into deciles, and they're like 10, 20, 30. Ooh, but the most I'm going to go is quartiles. That's plenty. So amazingly enough, P50 is Q2. P75. That's crazy. I like it. So take a minute and figure those 3 out for this set of data. Figure that out. I think I said I was going to use that other data, but I forgot, so it's all right. So again, allow it to make sense that if I want the number that has 25% of the data below it, I'm going to go 25% of the way into my list. So the first step for this guy is 25% of 10. If my list was 80 numbers long, I would do 25% of 80. Go that deep in. The second step is just an adjustment. Is it a whole number or is it a decimal? So what do you guys get for P25, Q1? Yeah, because if you do a quarter of 10, you get, 2.5. You round up to the, it's a decimal, so you round up to 3. The third one is the answer, 16. I love it. Let me stop there for a second. Is everybody cool with how you got that? No. So to find the number that has 25% of the data below it, I'm going to go 25% of the way into the list. So 25% of 10 is 2.5. So what I said here was, if it comes out to a decimal, you round up, and you take that one. If it comes out to a whole number, you average that with the next one. And I do this to see why this makes sense. The one in the middle is going to be the right one. So this came out to 2.5, right? 25% of 10. Round up to 3. The third one is the answer, 16. Now, obviously, what did I do with my data that you have to make sure is true? It's in order. If you didn't have it in order, you can make anything you want to be. That's no good, right? So what about P50?
19.
Ooh, I got dissension in the ranks. So what's 50% of 10? Half of 10 is? That's a whole number. So you got to take the fifth one and the sixth one and average them, right? So when you take the percentage of the list, if it's a whole number, you got to average that with the next one. If it's anything else, you round up and take that one. That's the 2 steps. Some of you guys worry. You look like you're in pain. This might be true. You're in thinky pain, right?
2025?
So you take
So you take the fifth and the sixth one and you average them, right? 1, 2, 3, 4, 5. So 19 and 22, 20.5. Take guess.
You don't round for this one, right? You don't round to get the...
No. I like it. Because, for example, if I rounded here, well, if this is 30 and 31, it'd be 30.5. I round up, it's only 31. It's not supposed to be either one of them. It's supposed to be in the middle. And finally, this guy. What's funny about this guy is how far in did I go from the bottom to get here? 3 places. So does it make sense to get this one? It would just be 3 from the top. Because they're sort of like symmetric on both sides. If you don't understand that, you can still go 75% of 10 is 7.5 rounded to the 8th number. Or you can just go 1, 2, 3. If I go 3 in to get to the P25, I go 3 down to get to P75 because they're 25% from both directions. If you don't understand it, just do it like we did the other ones. It works either way. So it comes out to be 29. All right, now you ready for something kind of silly? What's the lowest number? 11. It's crazy. What's the highest number? This is what's called the 5-number summary. Because it's 5 numbers that summarizes my data. You gotta love it. We're so creative, math people, with naming. So when they ask you find the 5-number summary, they want you to cut it in quarters, basically. Start, quarter in, 2 quarters in, 3 quarters in, end. I like it. And here's where the box and whisker plot. I'm sort of getting into 2-4 right now, but it only makes sense because the box and whisker plot says plot these in a weird kind of way. So this is from section 2.4. And we still have a few things in 2.3 to do, but it makes sense to do this right now. I think the book just calls this a box plot. But that's its full name. So anytime you want to graph data in this class, the scale has to be consistent. Please, dear God. So what I mean by that is, I want to make a scale that has all these data points on it, but the scale has to be true. It can't go 11, 12, 20, 38, 39. What the hell? No, it's got to be consistent. So you don't necessarily see any of these numbers on the scale. They just all have to have a place to go. So maybe I can start at 10. That's a nice whole number, right? And I want to make it up to maybe 40. So I can go by 5s or 10. Let's go by 5. 10, 15, 20, 25, 30, 35, 40. All right. Shoot. So I set my scale up so I have a place for all my data points to go. But none of them are necessarily the data points. But they all have a place to go. So above 11, here's what's funny. Above each of those numbers, put a line. So what do I mean by that? Like 11 is about right there, line. 16 is about right there, line. 20.5, line. 29. We get the idea, Jeff. 36 over there. Boom. Yeah, that looks just weird at the moment. Stay with me. You see this all the time. Is anybody thinking about transferring to university or something? Do you know that there's all these books out there, like the Princeton Review of Colleges and stuff? I don't know if you've ever looked at any of those books, but they very often tell you, they show you box plots, or they tell you the middle 50% of SAT scores is from here to here for our students. And that tells you like the heartland of that, right? Heartland. So watch. Here's the box. There's the box. The middle 3 lines do this with. Bam. And here's the whiskers. Boop. Show. So to my geeky mind, that looks like a really fat TIE fighter from Star Wars. You had the same? I've got you now. No, okay. Sorry. That's a little too geeky for this crowd. I got you. But what percentage? This is such a weird question to ask, but you can tell me this. What percentage of the data is in there? In that box, what percentage is in there? Why 50? Because what's this? What was this?
25.
So there's 25% below that one, right? And what's below this one here? Okay, yeah, this one. What's this one? This is Q1, Q2, Q3. So what's below that one? 75. So what must be in the middle? 50. So that's the middle 50% of your data. So this gives you a real quick idea of how spread out your data is. It gives you a real quick idea of where most of your data is, where the outliers are. Outlier. Reminds me of Children in the Corn. We have your woman. Oh, no children. Okay. It's a really good movie. So that's all it takes. You find a 5-number summary. You make a scale. You put lines. Make a box. Bam! You're done. It's beautiful. It's easy. Let it be easy so far. Yes, sir.
So would that not work as well with the haircut example, since all the answers were like on the low end?
It would still be a good visual of the data, believe it or not. Well, let's see. How many data points were there?
30.
30. Okay. So let's do that real quick. Nobody give them shit, because I was going to do something else anyway, so don't. You made a mistake. No. What's the lowest haircut price? 10. The highest haircut price was 60? Oh, that's right. What's the Q1? How would I figure out Q1? What are the steps? 25% of 30. Because it's how many data points there are, right? I'm going to go 25% of the way into the list. What's 25% of 30?
7.5.
7.5. Cool. So you round it up to 8. What's the 8th number?
15.
What is it, sorry?
15.
15? Okay. Does that check out?
Yeah.
Okay. And then what's Q2? That would be half of 30.